provided by the Institute and the MTI Educational Foundation. Before we introduce our speaker today, I want to cover a couple housekeeping items. First, we'd appreciate if everyone would silence your phones and turn them off. I know that it's instinctive to take pictures of the slides, but the whole sessions are being recorded and they're available to everyone who attends. So we please ask that you keep your phones away and be distracted with the speaker. So please be respectful of this request. Lastly, we're going fancy this year. There's no paper surveys this year, so the QR codes on the wall are where you scan with your camera to do the survey at the end of the session. So we ask that everybody take a minute to do that before you leave. If you forget or you're going to other technical sessions, that same QR code, once you scan it, you can pick the session you were at and do the survey then. And every time you do that, you're entered into a drawing for a $100 Amazon gift card. There's something in it for you. On to our session this morning at 8 o'clock. In this presentation, Greg Steiger will compare the use of bag filtration versus centrifuge filtration for contaminated quench oil. We'll also compare both methods of filtration on a clean quench oil. So please help me welcome the very smart Greg Steiger.
Good morning, my name is Greg Steiger. I am the sector manager for Idemitsu. I've been with Idemitsu since 2013, but I started in this industry in 1984 as a chemist. I have degrees in bachelor's degree in chemistry and a master's degree in materials engineering. So our agenda for today, we'll talk about the role of a quench oil. We'll talk about our test methods and how we evaluate the different filters for barrier or bag filters, centrifuge, and again our test parameters. We'll discuss the results, but this time we're going to throw a different test in there called millipore. I'll explain what that's all about. And then the conclusions. So what is the role of a quench oil? It's to dissipate heat, to do it quickly, safely, and uniformly. You have to keep oxidation, sludge, and scale at a minimum, because if you don't, you cannot dissipate the heat evenly. Sludge and scale are thicker and more viscous than a quench oil. Therefore, they dissipate the heat at a slower rate. Heat transfer coefficient, that's something that we always monitor and look for when we're evaluating a quench oil. It's how quickly does the oil or any other material dissipate heat. For a quench oil, it's uniform through the cooling process. It's determined by the viscosity of the oil, the additives, and the cleanliness of the oil. Sludge scale and oxidation. Oxidation will initially increase the heat transfer rate. It makes the oil's viscosity thinner. But as the oxidation continues, you start to form sludge. That makes the oil that much thicker and the dissipation of the heat that much slower. So what are the effects of sludge and scale? Clogged heat exchangers is the first thing that typically happens. Blocked lines and pumps. The variability in key parameters, such as your metallurgy, grain size, hardness, case depth, surface finish. If left unchecked, this is what you get. The part on the left was quenched in a heavily oxidized oil. The part on the right was quenched in a bright oil. So there's two very common types of filters: bag filtration or barrier filtration, and centrifuge. There's a lot of different types of centrifuges. Today we'll talk about the vertical centrifuge. Now the way the barrier filtration works is the oil enters into that canister, it's pressurized, the oil is forced through the bag filter, and it comes out. The centrifuge is more complicated, but I have some slides later. Now for our test methods, we couldn't very well duplicate what you see in your plants inside of our lab. So we used a vacuum pump and a centrifuge, wet benchtop centrifuge. So rather than using pressure to pass dirty oil through a filter, we used a vacuum to pull the dirty oil through a filter. We took a 300 milliliters sample. We passed it through a 75 micron filter. Ran a series of tests. We took another 300 milliliter sample. Again, passed it through a 75 micron filter, and then a 25 micron filter. 25 microns is about the most common you'll see in an industrial setting. For the centrifuge, again, we used the bench top. The first time we took a 300 milliliter sample, centrifuged it at 3,500 RPMs for 25 minutes. We took a second 300 milliliter sample and centrifuged it for 3 hours. So back filtration, it's the most common filtration method out there. It can be used as a single stage or a two-stage, and can be run in parallel or in series. It's economical, easy to use, easy to maintain, and it's rated by its pore size. Centrifuge relies on gravity and friction to separate the contaminants from the oil. It's also a more complex, more finicky and difficult to use filtration. So how does the centrifuge work? Well, first the oil goes in through number one. It goes through and it starts to spin, and as it spins, centrifugal force will throw the soil along the outside of the canister, along with the oil. There it begins to slow down. The contaminant is heavier and will fall out of the oil and eventually wind up down in number 5, while the clean oil then goes through the vortex and out through the top in number 4. There is some clean oil that falls into number 5. As that canister fills up, the clean oil goes back into that vortex, it goes back into your system. Once the sludge and debris fill that canister up, there's a notification that goes off. It's time to dump it. There's a gate knife that's closed. Everything is dumped, recharged, and started all over again. Now the testing we ran, pentane insolubles, that's the official ASTM test method name for the sludge. Millipore is not something that is typically run on a quench oil. The reason being is it's filtered through a 0.7 micron filter, but it gives you an indication of how clean the oil actually is. Carbon residue, we ran that because not only it's called the Conrad carbon residue test. Not only does the Conrad carbon pick up the sludge that's in the oil, but it also picks up the amount of quench oil speed additive that's needed, and it ensures that you have enough in there. Total acid value measures the oxidation of an oil. The oxidation level tells you how quickly you're going to start to form sludge. It's about 2 or 3 chemical steps before polymeric sludge is formed. And particle count, it's an ISO test. Again, it's not run on a quench oil very typically. It's typically ran when you've got very clean oils, like on a hydraulic oil, where you're introducing hydraulic oils into servo valves. We ran it here just to get an idea of how clean the oil is after filtration and centrifuge. So as you can see, after we ran it through a 75 micron filter, our pentane insolubles or sludge did decrease slightly. But it's not below a level that you would normally expect for a good operating quench oil. The millipore 189 or 195, that's the number of milligrams at 100 milliliters of solution. That's essentially the same number. So it really didn't change. Carbon residue, because we filtered out some of the sludge, you would expect the carbon residue to decrease. Because you're filtering it out and testing for carbon residue after the sludge is removed, so you would expect a lower number. Total acid number did not change. Filtration does nothing to influence oxidation of an oil. Particle count we couldn't run because everything was too dirty. Now after a 25 micron filter, you'll notice that we had a significant decrease in the pentane and solubles. But again, still not low enough to reach a level where we wouldn't expect to have any problems. The millipore did decrease, which we would expect. We saw a reduction in carbon residue for the same reasons that we did after the 75 micron filter. Again, no change in acid value, and particle count. The oil was still too dirty. Let's look at the centrifuge. Centrifuge, we had a very big reduction. We had a 0.12 weight% reduction, but again, it is still outside of the accepted levels. The reason you have accepted levels for sludge is you're not dealing with a homogeneous solution in a quench oil. So you have sludge that's just floating around in your oil. When it gets on the load, it's possible to have areas of that load that are within spec and other areas of the load that have softer hardness than what you would expect. That's because it came in contact with sludge during the quench process. The heat transfer rate was slower than the quench oil, and that's why you get lower hardness in some areas of your load. That's why it's very important to filter the sludge out as best as you possibly can. Now, after running it for 3 hours at 2,500 RPMs, everything comes back into spec. And if you'll notice, the particle count, this first number, 24 and the 18, that's a 4 micron. So it's the number of particles in 100 milliliters of solution that are greater than 4 microns. The next one is 7 microns, and the third number is 14 microns. So by cleaning it up, we actually clean that oil better than the virgin oil. But we still had sludge in it. We also worked with a customer on a 1-year study where they started off with a very clean furnace. It wasn't a new furnace. The furnace was 20 years old. But they cleaned it out as best they could. They opened up the heat exchanger, cleaned out the heat exchanger, put fresh oil in it. This was a hot oil. We ran a study for a year to test the efficacy of their filter. And it was a 25 micron filter. You can see with the pentane and solubles, we started off very low. And even after a year, we were still very low. The particle counts are essentially the same throughout that entire year. So for a bag filter, the pentane and solubles are significantly reduced when filtered through a 25 micron filter and not through a 75 micron filter. But they remained outside of the suggested limits even after filtration. The total acid value was unchanged, and the oil was always too dirty for a particle count. With centrifuge, initial centrifuging lowered the pentane and solubles by 32%. Doing it for an extended time brought it back into specifications. Carbon residue was lowered as some of the pentanes were removed through the centrifuging process. Total acid number again was not changed, and particle count and millipore were greatly improved. So comparing the two, bag filtration, smaller pore size is more effective than a larger pore size. Pentane and soluble loads remain high even with a smaller pore size, and we could not obtain a particle count because the oil was too dirty. Centrifuges are more effective than bag filtration units. The longer an oil is centrifuged, the more effective that centrifuge is. And lengthy centrifuge can bring back an oil to its original standards. So our conclusions were, a large pore size filter has very little effect upon the tested parameters. Filtering through a 25 micron filter does improve the sludge, but not to an acceptable level when you have powdered sludge to start with. Both centrifuge results show the marked improvement over our barrier of bag filtration. Our year-long study of the pentane insoluble showed that if you start with a clean furnace and a clean oil, it's possible to keep the oil clean with a bag filter. Overall, if a bag filter unit is used with a clean quench oil, it will work. But if the oil is too dirty, a centrifuge has to be used. Now, there are several different ways to centrifuge. The vertical centrifuge that we talked about here. There's also a portable centrifuge that you can use to go from furnace to furnace. There's also companies out there that will bring a centrifuge truck into your plant and centrifuge right on site and add oil back to the oil that they take out because it's dirty. Choices are really up to the individual company and consumer. The vertical centrifuge is the best option because it can be used in a kidney loop system on every furnace, but it's also the most expensive. And here's my contact information, and before I open it up for questions, I'd like to thank Michelle Bennett here for doing all the research for this talk. Are there any questions? Yes?
Are the production centrifuges normally sized to give you a long centrifuge? Or if you've got a 5,000 gallon tank, are you running it continuously and it's never going to get to that point where it cleans up good?
If you're using a portable centrifuge, you're going to need a long centrifuge cycle. But if you're using one like a vertical centrifuge and you put it on a kidney loop system, you don't need that long of a centrifuge cycle. Yes?
Aside from investment costs, what do you think the biggest challenges with centrifuges and just industrial IQs and pusher furnaces?
I have no idea on costs. That would be,
I mean, you're not getting filters every time, so that's
Right.
cost savings over the long term. But
yeah, but when it comes to cost, I don't know what the costs are.
I mean, what are the challenges associated with keeping centrifuge? Is there any adjustments that?
The challenge would be if you're going to use a centrifuge cart because you're moving it to numerous furnaces, you've got to keep a long centrifuge cycle. If you've got the vertical centrifuge, you just have to size it properly so that trash receptacle is large enough that you're not having to dump it frequently. Yes?
The centrifuge in the container that catches the sludge and everything that filters out, is there going to be some oil that might have been, still in your system in a bag style filter? And you think that it would collect oil at a rate where you would have to top up your quench tank oil more often with the centrifuge versus the bag?
You will get a little bit of more oil coming out with the sludge than you would in a bag filter, but not at an appreciable amount. Jerry?
Is the sludge generated from material on the work, or is it a result of the quench operation?
The scale comes from the work material, and the sludge comes from the oxidation of the oil. Mike?
What's the life expectancy of the bag filter?
That's going to be difficult to answer. And typically, for a clean solution, clean oil, you can probably go a couple of weeks. On a dirty one, it could be a matter of hours. We've had customers that change their bag filters once a shift. Teacher?
What's the measure of oxidation of the quench? Is that total acid number?
I'm sorry, I didn't hear.
What's the measure of oxidation of the quench? Is that the total acid number?
It is.
Okay.
The total acid number, it titrates an organic acid in the oil, and it's what you can measure before oxidation starts. So as your total acid number increases, you know if left unchecked, your sludge is going to increase.
That can be reversed with filtering?
You can't reverse oxidation in a quench oil. You can only slow it down or dilute it. And the way you dilute it is by adding fresh virgin oil to the quench tank. You can also see an increase in your total acid number and not see an increase in your sludge because your filtration system is working. Yes?
Did you test for load one time a day?
No, we did not. The reason being, Dan, is because the bags become so expensive, and the smaller the micron size you get, the more expensive the bag is, and the more frequently it has to be changed. So 25 micron is typically what we recommend to our customers, and that's why we stopped that. Yes?
At what level do you start taking out additives?
You really have to get a pretty tight filter, and it's usually a micron or less.
Okay.
And you don't really have to worry about filtering out additive levels in an oil with quench oil filtration. Yes?
We have batch releases and with pretty heavy mass loads that will continually after that accelerator. Would you expect we would probably still have to do that with like a centrifuge?
That's a function of the oil as opposed to a function of the filtration units. So if you're using an oil that requires an accelerator, you have to continue it. If you're using an oil that doesn't require an accelerator, you wouldn't have to add an accelerator. Any other questions? Thank you all for your time.